Hello guys, today we are going to learn how to solve a quadratic equation or a question that is related to curve, quadratic curve or any straight line in this form. Usually you need to pick up two parts in it. You need to be given an equation of a line, you can clearly see that here, and then there is an equation of a curve here. Okay, and the question is clearly telling you find the set of values of k for which the line and the curve have two distinct points of intersection. That means here the question is telling you that there is a line, equation of a line, and then there is a curve, a quadratic curve, because I got to know that from this equation, and the line is intersecting this curve in such a way that it gives you two distinct intersection points. Okay, in that case, what did we learn earlier? Something or some fact about discriminants. If you know about discriminants, it's a quadratic formula, b square minus 4ac. You can see there are three facts: if it is equal to 0, greater than 0, or less than 0. When it is greater to 0, that means it will have two distinct roots, and when it is equal to 0, it will have one root or equal root. When it is less than 0, it will have no root. So based on these facts, we will have to apply our knowledge. Our question here clearly tells you that it should have, the line and the curve have two distinct points of intersection. So out of these three, which property will you apply the most or best fit? Obviously this one. So using this fact in mind, we need to keep this fact in mind: b square minus 4ac less than, greater than 0. Okay, so now we need to make sure that these two lines are intersect, or this curve and this line have to intersect. So in order to equate them, what do we need to do? We need to first of all write down their equation. That's the equation of the line, and this is the equation of your curve. What will we do now? How do we find the point of intersection? By simply equating the two equations. So equating the two equations means, okay, you see both of them are equal to y. So what we will do, we will simply equate them. So 3x plus k is equal to x square plus kx plus 6. Now if you have understood this, what you will have to do, collect all these terms on one side. So x square plus kx plus 6. So because there are three terms here, I'll shift this to the other side. So it will become negative 3x. And if I move this to the other side, it will become negative k. And what is left on this side? Nothing. So we will mark this as equal to 0. Now that we have this expression, now we have to simplify this further. Collect the like terms. What are the like terms? Now you see this x terms are like. So I'll write x square plus kx minus 3x together. Obviously you cannot add them because they are different numbers, plus 6 minus k equal to 0. But clearly you can see x is common here, and these are two individual numbers which has no variable on it. So that's a constant. What is that? That's a constant. Now what I will do is, I will collect the x term. I'll take out the common. So I'll be left with k minus x. Take the x out, plus 6 minus k. I'll keep it together because I want this term to be taken as same. No sign is affected here. So now this is in the form of quadratic equation, so which is ax square plus bx plus c equal to 0. So in this question, compare them. What is a? Your a is 1 because the coefficient here is 1. Your b is k minus 3, and what is the c here? 6 minus k. Now that we have got to this point, what is the formula that we will apply to find two distinct points of intersection? b square minus 4ac greater than 0. So b square minus 4ac greater than 0. Substitute these values. What is your b? K minus 3 the whole square minus 4 times 1 times 6 minus k greater than 0. Now that we have got an inequality here, expand this. So we'll get k square minus 6k plus 9. Multiply this, what do you get? Minus 24. Minus into minus plus. What is it? 4k greater than 0. Collect the like terms again. So we get k square minus 6k plus 4k will be negative 2k, and minus 15 greater than 0. If you see, this is how far it goes. Now can you simplify this further, because this is a quadratic expression again. Negative 15 will be 3 times 5. Now you see the largest numbers needs to be negative, so negative and positive, so final answer would be negative 2. So we can say clearly the expression or quadratic factors here are k plus 3 greater than 0 and k minus 3 greater than 0. Now unlike quadratic equation, you cannot take this expression out. You have to apply the sine rule. How do we apply the sine rule? It's quite simple. What is k plus 3 equal to 0? It will be k equal to negative 3, and k minus 5 equal to 0 will be k equal to positive 5. Obviously the first number on the number line will be negative 3. So what I will do, I will leave a box empty, a column empty, and write the second expression or the second factor, which is 5, and leave another column empty. And here also I will leave another column empty before this, and below this I will write our first factor, k plus 3, and here in this row I will write our second factor, k minus 5. Okay, now k plus 3, when it is 0, the answer is negative 3, and k minus 5, when it is 0, the answer is 5. So on a number line, all the numbers before 0 are negative, and all the numbers after 0 are positive. Similarly in this row, all the numbers before 0 will be negative, and all the numbers after 0 will be positive. Now all we have to do is simplify this further. So negative times negative will be positive. 0 times any number will be 0. Positive times negative will be negative. Positive times 0 will be 0. Positive times positive is positive. Now our expression is telling us that we are looking for factors which are greater than 0. That means we are looking for positive numbers. So when is our expression becoming positive? Our expression is becoming positive here, and our expression is becoming positive here in the results. So when is it positive? When it is more than 5. Consider this as a number line. So when it is more than 5, it is positive, and when it is less than negative 3, it is positive. So how do I write the range or set of values of k? Is, or are, k must be less than negative 3 and k must be greater than 5. So what is our expression finally? K must be less than negative 3 and k must be greater than 5 for positive. Do you get this, everyone? So this is the whole solution for your I'll post a picture at the end for you to see it, or I'll post this in the solution at the end so that you could see it. Okay, thank you so much. Have a lovely day. I hope you got this, and for more videos like this, let me know.